everybody, my name is Zaina and I'm with the Child Creativity Lab, and today we're going to be doing an experiment called Ice Cube versus Wire. In this experiment, we're going to see if a wire connected to some weights can cut through an ice cube but somehow leave it whole. We're going to learn about the density of water as well as a property of water called regulation. In addition, we're going to be learning about how pressure affects this experiment, and we're going to come up with some hypotheses about pressure. Let's get on to the materials. The first step of getting our materials is actually going to be getting our experiment set up. To set up this experiment, you're going to need 2 stools or chairs of equal heights to balance a long object on. Now that you have your chairs or stools set up, you're going to go ahead and grab a large object like a book or a piece of wood that can lay across both chairs and go from one of them to the other. Once you have your book or piece of wood connecting the chairs, you're going to go ahead and grab something like a towel or a piece of felt that will catch the water that is melting from the ice cube. Now that you have everything set up, it's time to go to the rest of our materials. Now that we have our experiment set up, the next step is to get the rest of our materials. The first material that you're going to need is wire. It doesn't matter how thick it is, it just matters that you have at least 18 inches of it. The next materials you're going to need are some type of weights. I'm just using 2 containers of juice, but you can use liters of soda or actual weights if you have any. And the last thing that we're going to need is a few ice cubes. Now that we have our materials, the next step is to go ahead and attach our wire to our weights. I've already cut about an 18-inch piece of wire, and now I'm just going to attach one side at the top of the bottle and attach the other end of the wire to this top of this bottle. Since you can use any weights you want, the key is to just have them connecting with the wire and be able to lift them with the wire without them falling. Now that we have all of our materials done and our experiment is set up, we're going to move on to the fun part, which is actually putting the experiment together. First things first, we need to place a piece of ice on the middle of our experiment. Next, we're going to go ahead, grab our weights, and place the wire directly over the ice cube with both weights hanging down. It should look something like this, with the wire cutting directly through the ice cube. Now we wait and watch as we slowly see the wire melt through the ice cube, splitting it in half. Did your experiment work? If it did, you should be left with a slightly smaller ice cube, but one that's still completely intact and not split down the middle. Isn't that amazing? For the next part of this experiment, you can mess with and change the different weights that you're using to see if that has any effect on your experiment. If you add more weights, will it make it split the ice faster or slower? You can come up with hypotheses and test them using this experiment. I hope you guys had a lot of fun experimenting with your ice cube and your wire, but now it's time for the explanation as to why this experiment works. This experiment may seem like magic, but the truth lies in 2 of water's properties: its density and a property called regulation. Ice, which is the solid form of water, is less dense than liquid water. So when we put a lot of pressure on it, like a heavy wire pressing down on it, it becomes less dense and starts to melt. As the ice melts, the wire is able to slowly move through the ice and cut it in half. But the ice maintains its shape and stays in the same form that it had from the beginning. This is because of a different process called regulation. Regulation allows the ice to reform and freeze back up after the pressure from the wire is gone. So as the wire moves down, the ice above the wire is able to freeze and keep its original shape. This is how the experiment is able to work and how the ice looks the same at the end of the experiment as it does at the beginning. To truly compare the pieces of ice to see if anything has changed, you can take the end piece of ice from your experiment and a brand new piece of ice and compare them. Are there any similarities? Are there any differences? You can see the full extent of changes that the wire did to the ice that was in the experiment. I hope you guys learned a lot from this video, and I hope you had a lot of fun doing this experiment. Thank you so much for watching, and see you next time.